Hey there, let me show how to generate source code when debugging a .NET application. So, generally, the source code of an application is available during debugging. However, sometimes you might have an exception in a location in which you didn't have the source code. If the application is written in .NET, it's not too bad because you can actually generate the source code from the running assembly. Let me show a really quick way to do it using a single WinDBG plugin. The plugin we will use is this plugin, the plugin Netext. This plugin is a single WinDBG plugin that has a lot of commands, but it has commands that can be used to generate source code. This plugin does not need the SOS or SOSEX plugins to be loaded ahead of time. It can actually just be run on any .NET assembly. I will put a link in the description below on where to get this plugin. Basically, it's just the GitHub site and you just go to releases and download an instance of the plugin. There is a 64-bit version and an x86 version. Just choose which one you want. Download both. The plugin is really easy to use. So let's just jump into an instance of WinDBG and use this plugin. So let's switch over to WinDBG. So what I have on the screen is I have an instance of WinDBG and I have a program running over here. This program is just to illustrate this issue where all the program has is one button called generate exception. I don't have the source code for this program, but we're just going to generate the source code and debug this one exception that's going to be generated. So the first thing I'm going to do is I'm going to pause WinDBG and I'm just going to load the plugin. So what I've done is I've actually downloaded the plugin and I've actually just expanded it into this folder over here. You can just load it with the .load command. If everything is loaded fine, you'll get a bunch of instructions over here. The instruction to index is probably the most important instruction, but we're going to skip all that because we don't really want to look at the memory. We just want to use it to basically generate source code. So let's resume the application and click the generate exception button. When I click on the generate exception, I can see that I get a CLR exception. Now the application didn't crash. What's happening is that this exception is actually getting caught somewhere in the application. That's why it didn't crash. So let's get WinDBG to trap the exception. So what I do is I just run sxe CLR and this just sets a trap. So if I resume WinDBG, I just press F5 to resume WinDBG. And if I generate exception, it's now going to trap the exception. Let's try to view the stack. Now this is a .NET application. So if I try to view the stack by typing K, I'm just going to get the native functions. So I can see that the native functions are not going to decode properly because K is for native stacks. So the frame in the manage code, well, WinDBG doesn't know what to do. Now technically I can load the SOS plugin, but let's just go ahead and use the native functions and generate the source code. Now to generate the source code, what we need to do is we need to take the memory address of the function that threw the exception. So we run this command, we run the command make source, w make source. This command is part of the plugin we loaded earlier. And the address we want is exactly the return address of the throw. So if we run it like that, this will actually generate the source code. There we are, it's generating the PDBs and the source code and it's going to open it in another window. Let me show an example of that. Let me take out the application and the window kind of looks like this. It's just a floating window that contains source. But the important thing to note is that all the source here is actually generated from the assembly itself. It's not taking the source code from Visual Studio. So this is really handy because you don't even need the solution that made this project in the first place. If we look at the generated line, it just says throw new exception with a message in the middle. Let's just verify that this is correct. If I load the SOS plugin like that and I run PE, I can actually see that it is a system exception. Yep, that's correct. And the message does say random exception. So it definitely is correct. Now, if we close the file, we can actually open it again by just running w open source. Let me just remove the screen over here. There we are. We can actually just run w open source and put the address back in. And this will actually open the source code again. So let's go ahead and do that. And if I open the screen, there we are. We get the source code back again. Let me just clear the screen. There is more we can do from this point. If we want to put a breakpoint exactly on the function before the exception is thrown, we can use the generated source to actually find the location where to put the breakpoint. The first thing we need to do is we need to find the method table ID. So one handy trick to do that is we can run wstack. What wstack does is it dumps out all the objects on the stack, but it gives us the method table ID. Now, based on the source code that was previously generated, I kind of know that the class that threw the exception is actually some class. It's a method in some class. The method table ID is this ID over here. Now, if I run wclass with that ID, it's going to generate all the methods that exist, and it's going to give me a pointer that I can click and it will add a breakpoint. So let's do that. So I know that the method is called do something, which is the last one over here. I'm going to click on it and it's going to add a breakpoint to the method do something. Let's resume the application and give it a go. So this is the application. So I'm just going to resume WinDBG. Now, if I click on the generate exception, observe that the source code appears. That's because I had generated it earlier. This source code is basically, it's showing me the line is actually do something. It's because this is the header of the function. That's what WinDBG does. It just takes the next instruction pointer. This line has not run yet. So there is actually no exception. It is actually a breakpoint that has been hit. We can actually verify that with BL. That shows us that we do have one breakpoint. It is breakpoint 0 and breakpoint 0 has been hit. Also observe that the location for the actual source code, it seems to be in the temp folder. That's correct because it's generated source code. It's not actually in any Visual Studio project. Anyway, this is quite a handy plugin if you need the source code in a pinch. The way I use it is that if you have an exception somewhere deep in the .NET framework or somewhere deep in some SDK, you can just tell WinDBG to trap the exception, but you always end up in a location where you don't have any source code. Really handy way, just generate the source code and you can read what exactly is happening. It might be useful in debugging, but I find that the best use is trying to figure out what parameters went into a function or what was the condition that threw an exception. I have used many enterprise level decompilers in the past. They do work, but the effort to set it up and to actually decompile, sometimes I just prefer to just use WinDBG and generate just one line of source code or maybe one function or maybe one file. I find it much simpler and more productive. Anyway, let me know in the comments below if you have used this technique before or if you have used any other technique that is equivalent to this technique of just generating the source code from within WinDBG. Gentle reminder to subscribe, give a like and hit that bell icon to be notified of new videos. As always, it's been a pleasure bringing you this information. I am High Voice, signing out.